Hey YouTube, welcome to part 3 of my DIY electric skateboard project. I already filmed the intro to part 3 a couple days ago, but I ended up going into all the technical difficulties I was having and my workarounds, and it ended up being like a 20-minute long video. And I figured the average viewer of these videos are just people wanting to see my build, because most of the YouTube videos are just people showing off, their builds. So I'm going to not talk about any technical stuff, and then, I can always make a separate video later. So yeah, I've been working on the project a whole bunch. Did have one problem for some reason, and in part 2 you see me design this 3D case and put together a Frankenstein of a transmitter. Works great, but for some reason the battery went dead. Just battery's totally shot. I don't know why. Now, I was trying to design this case to screw together so I could service it. And then I just got tired of having problems designing the case, since I'm not good at 3D design. So I just rushed it and I super glued the case together. And so in order to take it apart, see what's going on with the battery, I actually got to destroy the case. I don't want to do that because functionality, the transmitter works perfectly fine. So the workaround at the moment is to run the transmitter off this USB battery pack that I have. I'll put this battery pack in my pocket, just plug it into the bottom of the transmitter, and transmitter works great. So that's just a temporary workaround. I'm kind of shifted my focus more on getting a functioning board. So I have a board to ride around on, and then I can go backwards and fix any things I skipped over. And the transmitter, I have a better idea for it, so I might just, when I get the board running, if I want to go back, I might just build a new transmitter. And then I've been working on the electronics. Now, so this is what I have so far. Now I'm adding a controller board that I'm decided to point-to-point solder it to get it working. And then, like I said, I have plans to go back and I'll probably make some design changes and just etch my own PCB. But for right now, I'm just point-to-point soldering it. Now the microcontroller is totally unnecessary. I'm just adding it in there for peripherals, and because I like doing microcontroller stuff. But this is what I have so far. I'll explain the control board better in a later date what it does. I have my two vests, and I have them mocked up here. I'm going to control the vests using PPM in each separate vest. I was going back and forth between doing that or a master-slave configuration over the CAN bus, but I decided it was just a lot simpler to do PPM. So I'm going to do that. And then I've been experimenting with these WS2811 LED strips that's going to go on the bottom of the board. And I have quite a bit to add on the control board. Like, I want to add headlights, I want to add brakes. But I'm at a point where I realize that, okay, this 9x15 control board is more spacious, plenty of room for anything I want to do. So I knew that my VESC enclosure, if I had it designed this and the VESC, that the enclosure would be big enough. So I went and I designed my own 3D printing enclosure. Like I said, I'm kind of new to 3D printing design. I used Fusion 360 and I designed it totally from scratch. I did get inspiration from the Boosted Board Killer YouTube video. He actually has the STLs freely available for his enclosures. So at first I thought, well, maybe I can take that STL and kind of cut it and stretch it, but it just wasn't going to work out. So I created a design totally from scratch. But I did take styling advice, or the design of it. I did kind of steal the design from that project, although there's some of the curves that he did, I couldn't figure out how in Fusion 360 how to curve it out. I can only know how to Oh, the name escapes me at the moment. I'm bad with names. You flare. I'm going to post the name of what I know how to do, whatever's posted here. But as far as like making radiuses that are different, that have different slopes and stuff, change their slopes, I couldn't figure out how to do that. So it would have looked a lot cooler if I could have done that. And so right now I'm just pretty much waiting for this to finish printing. And we'll see how well it actually works. There's a couple of unknowns on it, so hopefully it actually fits. So that's what I'm waiting for now. We're 1 day, 14 hours in, and it should be done in no less than 5 hours. I think it has 5 more hours. So I'll see you back in 5 hours. Okay, so the print has finished, and as far as my 3D printing skills go, this is a perfect print. This is as best as it can get. I can never get any better quality than this, so I'm happy with the way it came out. I did start to have a bit of lifting, and so that's why I started putting some Scotch tape there, but it never actually came up and shifted or anything. And so we'll I have it printing on a raft. Oh yeah, by the way, this printer is a CR10 version 2. It has a 300 millimeter print bed, and this enclosure is exactly 300 millimeters long. So I didn't really leave any room to spare there. So as you can see, I went and I put a curve in there, so the whole thing's on supports. Let's see how easy this separates. Okay, so preliminarily, that's what it's like. I calculated this angle of curvature using math, so it's going to be interesting to see how well it fits. Wow, the funny part is, it looks good. Looks like the curvature. If I did that right, I can't believe it, because I use those math equations that whenever you learn them, you always think, am I ever going to use this? It's almost perfect. There's a little bit of a gap there, but I'm not going to worry about that. The only thing is, it doesn't leave much room for the battery. But yeah, that's great. So another thing is, got to make sure. See, it's got to be moved forward a little bit so that, like, it's not going to hit there, not going to hit there. So perfect. And then the ESC wires will go in there. Man, that actually turned out really good. So cool. Okay, I thought I would show you the system I'm using to secure the electronics to the enclosure. Obviously, I decided just to print out a flat bottom and then put my mounting points in later. So what I came up with was to just 3D print these brackets, put heat threaded inserts in them, and then I'll thread these anti-vibration mounts, and then I was gonna super glue these brackets to the bottom. So as you can see, this one is for the vest. So you secure the vest like that. Oh. And then super glue the mount to the bottom, and hopefully that'll keep everything nice and tight. So that's the plan. I also went and I printed out these little 3mm plastic washers, because some of these on the vests here, you see that's, you can easily short out between the two outputs, the two phases there. So yeah, that's the plan. I'm gonna go ahead and super glue this down, and we'll see how it works. Okay, it seems like it'll work properly. That looks pretty nice and square. So I only have one shot to do this. That's the one thing about 3D printing, is that super glue works pretty well with it. Okay, so I made little individual standoffs for the main control board because the board's so big, and I actually had to, I messed up. I cut notches here, but I ended up having to cut notches here to get it past the post. So I'm going to use this circuit board for the anti-spark circuit. So the anti-spark circuit board is going to go there, control board's here, and then the capacitors for the VEC is go right up against this control board. So my tolerances were a little tight, but I guess it could have been worse. Remember, originally I just designed this control board for this board and the VECs. But now I'm going to have to try to figure out if I can super glue this in place, because it's kind of like a puzzle piece trying to get this circuit board in. And it's because I put lips on this case. And I did that last minute, put lips on the case, because that what I was trying to follow, that boosted board killer one, did that. And the thing is, I actually don't have enough. I only have 12 of these anti-vibration mounts, so I'm going to use the last 4 on this, or I may not use them, may or may not use them on this anti-spark circuit. The control board, it's too tall. This gyroscope's too tall, and I don't want this gyroscope sticking up past the cover in case something hits the cover. But that gyroscope's like $2, and I have it removable, so I guess really not that big of a deal either way. This is going to be super sloppy with the glue, because I just got to put the glue down here and press the circuit board down on it. I mean, what happens is I feel like, okay, I spent enough time designing this on Fusion, and then I stop. You know, if I would have spent an extra like 2 hours, I guess I would have had this all figured out. Okay, so now I want to try to place the circuit board down on the glue like that. And like I said, the thing about using this 3D printing material, super glue works super well on it. Even this is really my I've used PETG in the past, but nothing this major, not for a major project like this. So, biggest thing is making sure these notches are in there, and they are. Okay, we'll see if it takes. Okay, so I just noticed now when I walked up to the workbench, big mistake number 1. And it's probably not the first mistake I made, but it's the first mistake I'm humble enough to admit that I did. Is I designed this with this corner part to be in the rear. And when I went and I put the mounts down for the ESCs, I put the ESCs on this side, not this side. And I was like, man, I can't believe that. And the big thing that it impales is these spots for the 2 buttons are in the back now, not in the front. But that's actually not a big deal. I went and I laid it on top of the board and I moved the wheels because this is cut out hypothetically for the wheel travel to get this box closer to the wheels. But really, it doesn't make any difference because these cutouts doesn't allow the box to get any closer to the wheels than this side. And these holes are 100% identical on each side. So it's not really that big of a deal. It's just, this was supposed to be in the back. I'd like to say that, oh, I did that on purpose to make it more aerodynamic, but the problem is I'm going to have a battery container in front of it, and I don't think I can make the battery container this small. So that's the big mistake number 1. But the batteries did come in. I did kind of cheap out on the batteries. These were on sale. These Zippy 4 ampere hour or 4,000 milliampere hour, however you want to call it, 6S batteries. And I went ahead and bought a prefab connector to make them 12S. Like I said, I bought these batteries because they were cheap. They didn't use the XT60 or XT90s. They used these connectors, which I kind of like them. I got a whole pack of solderable ones. And Amazon Prime does not offer 2-day shipping anymore. And Hobby King, and I was trying to put the order together to get free shipping. Hobby King 10-gauge silicone wire was a hot commodity. I mean, they had a shortage. The only one I could get was 1 meter of 10-gauge. I couldn't even get another one. They only had one in stock. If you wanted 10-gauge wire, this is all I got. So even though it's a little on the short end, I think it will work. I have to go and be very frugal with this, but I think if I'm frugal with this, it will work. So the only thing that needs to be mounted into the board is the anti-spark circuit. So I got to figure out how I'm going to do that, and I think I'm ready to start wiring things up. I think what I'm going to end up doing is taking these 2 copper wires and bending them over 180 degrees and then solder on these terminals this way so it keeps a low profile. I think that's probably the best way to do that. And another thing I'm going to do, and I'm actually going to do this next, is I'm going to put a voltage spike diode right here across the terminals of these VESCs to prevent them from burning out from high reverse voltage going through. And for that, I have these PGKE 56CA diodes to put across that terminal. So I'm going to solder these across these terminals, and then I'm going to conformal coat these ESCs. And then once I do that, I can start wiring everything up. I do want to go through, there's a lot of like residual from, white residual from the, it got all over the circuit board, got over the whole enclosure, this all over the circuits for the super glue, but I still got to super glue the bracket for this soft start, not anti-spark down. So once I get that done, I'm going to take the circuit boards out, clean the enclosure, and then put everything back in. But I'm going to go ahead and get these ESCs ready. I think I'm going to reuse these pigtails here because the capacitors are already soldered onto them. And I think they are long enough to tee them together. Okay, I misread this label. It's a P6KE56CA. But these diodes really don't have any stripe on them, except I guess the band you would consider the labeling. So I have my meter on Diode Check. So That should be forward bias. Oh, you know what? I bet you I can't check this because this is a 9-volt battery. Oh, I can't check this because this is a 9-volt battery. Okay, I checked Google, and the reason they're not marked is because they're bi-directional diodes. So I don't know if I messed up there or not. Theoretically, they only conduct after they go over 56 volts. For 12S, if you have 56 volts on the system, that's like a fully charged battery is like 52 volts. So it's definitely bad. So I'm just going to go ahead and go for it. And if we let the black magic smoke out of it, then that would be it would make for a good video, right? So I'm going to just go ahead and add them to the back here. Okay, so this bottle's old, but it's silicone modified conformal coating. And started doing this because of my quadcopters. I have sunk a quadcopter in a body of water before. But this stuff's pretty much awesome. The only thing that scares me is there is a crystal oscillator up there. Like in the quadcopters, you just had to worry about I'm guessing the crystal oscillator will be fine. On the quadcopters, you got to worry about the gyroscope and the altimeter. But yeah, you just brush this stuff on, let it dry, and this stuff will actually it prevents shorts because of moisture. And if you need to solder anything on, this stuff will actually just melt away with soldering iron. I forget how expensive I bought this bottle a while ago. I forget how expensive it is. It also leaves like a cool UV coating. Watch, there's probably some reason why you shouldn't be putting this on your ESCs. And someone's probably commenting, no, don't do that. And then later on I'm going to smoke these. Okay, so very nerve-wrackingly, I centered the box to the board, which I kept on second guessing myself, so I'm just going to call this center. And I'm going to use these threaded nut inserts and for 1/4 20, and it says for softwood use 8.5mm bit. If too small, try 9mm. For hardwood, try 9mm, go up to 3/8. But I'm going to try one hole, and I'm going to start it with the 1/4 inch just because these holes are 1/4 inch. And I'm hoping that the enclosure will help guide me down to keep a straight hole. But this is very nerve-wracking. You only get one shot. So here we go. Okay, that went through really easily. So okay, so that went through very, very easily. Yeah, a nice clean hole, looks straight. So I'm just going to step it up till I get to that 8.5mm. A little bit of crackage on the top. But to tell you the truth, I think the grip tape's going to lay in there just fine. Okay, so my camera ran out of batteries, and then I kind of had a little bit of insomnia last night, so I just went ahead and put everything back together, wired it all up, and I'm pretty happy with the way it turned out. You know, when I watch all these other people do their DIY builds, whenever they open up the enclosures, it looks all like a rat's nest, so I wanted to try to keep it neat. So I think it looks pretty neat. Just using 10 gauge wire, using these 4mm connectors. Just use some like butt splice connectors, so then that way I can just remove the control board easily. And I temporarily just made this long and put a connector on the end to plug the batteries in. So we're ready to give it the Blackmagic smoke test. So you'll have to check back on the next part to see if it blows up. Thanks for watching.